Hello, this is Mr. Stansbury. I'm going to take you through the notes on direct variation. At the end of this, you should be able to say, I can show that two variables can be directly proportional, and I can find a formula connecting the variables. Okay, so two variables are directly proportional or very directly if multiplying one of the variables by numbers results in the other one being multiplied by the same number. Okay, so if variables x and y are directly proportional, we write y varies directly as x, or y is directly proportional to x. Okay, if y varies directly with x, then y equals k times x, where k is a constant called the proportionality constant. Okay, when y is graphed against x, it's a linear graph that passes through the origin that has a slope k, and it's super important that you realize that it passes through the origin. If it doesn't pass through the origin, then it's not directly proportional. Okay, so let's take a look at example 1 here. For the table of values, plot the graph of y against x. So we're just going to graph these points here. So we get 2 and 5. 3 is at 7.5. Ooh, we're going up to 15. So let's make all these go by 2. So x is at 2, y is at 5, so that's right here. 3 and 7.5, right? So that's going to be, that's 10, that's 8, so here's 7, so 7.5 will be right about there. 4 is at 10. 5 is at 12.5, which is about right there. And then 6 is at 15. Okay, so let's see, that's 10, 14, that's about 15 right about there. So hopefully you can look at that and say, hey, that's going to make a nice straight line, isn't it? And it is going to make a nice straight line that just so happens to go right through the origin, and that's pretty important to know. That's what makes this a direct variation problem here. Okay, so these here, we've graphed our lines there. Okay, and then now determine whether y is directly proportional to x. If it is, find the proportionality constant. So they're basically saying, okay, yes, it makes a nice straight line that goes right through 0, so it's directly proportional. Okay, and then now we're going to find the proportionality constant, which we call k. All right. So really, I mean, like the quick and easy of this, the proportionality constant, that's just the slope of the line, right? So if we look at this, we start at 0, 0, and we go up. A nice little intersection is right here at the point 2, 5, right there. So the rise from 0, 0 up to 2, 5 is up 5 over 2. So it's up 5 over 2, which is 2.5, which is our proportionality constant. Okay, let's take a look at example 2 here. Suppose t varies directly with v and t equals 14 when v equals 9. Find the proportionality constant k. So if we have t varies directly with v, what we know is that t is going to equal our proportionality constant k times v. Okay, so really if we're looking for k, we divide both sides by v. And we know that our proportionality constant, when we have direct variation, is going to be t over v. And this t is always going to be the first part. That's going to be the top. So whatever comes first here is going to be our numerator. And then whatever it varies directly with v is going to be in the denominator. So in this case, it's going to be t is 14, v is 9. So if we take 14 divided by 9, we get that k equals 1.56 would be our proportionality constant. Okay, let's take a look at the second part of this. We're going to take a look at these examples here to help us understand, but before we do that, we're going to do a quick little comedy break. So example 2 here, suppose t varies directly with v and t equals 14 when v equals 9. Find v when t equals 40. So from the problem that we just did, we figured out that our k was we did 1.56. Let's go a few more decimals out just to make sure. Well, we'll go one more decimal out just to make sure that we get a good accurate answer here. So if k is 1.556, we know that t is going to equal k, which is 1.556 times v. Okay, so now all we need to do really here is just plug in whichever piece we have. We have t equals 40, so we'll do 40 equals 1.556 times v. So to get v by itself, we divide both sides by 1.556. And that should get us a pretty accurate answer. Let's check that out. So 40 divided by 1.556, and that gives us 25.7, we'll call it. Okay? And we can use this same formula right here over here, and we get t equals 1.556 times v. And now it says find t when v is 30. So t equals 1.556 times 30. So we'll just get our calculator back out. 1.556 times 30. And that gives us 46.7, we'll call it. T equals 46.7. Okay? Okay, that's all we have for a direct variation. If you have any further questions, please feel free to ask in class. Thanks.